in New York. I'm Jos Salvo, manager of the laboratory up at GE Global Research. And I would like to tell you a little story today. As I was coming down here, I thought, what a fantastic venue for this event. Transforming industry, transforming business again. A lot of this started back over 100 years ago, just a few blocks from here, Lower Manhattan. One of the world's most famous innovators and inventors, Thomas Edison, created the first commercial power grid just a few blocks away on Pearl Street. It changed the way people worked, it changed the way they lived, and it allowed the creation of the beautiful skyline we can take advantage of today all around us. It has literally sustained a wave of innovation for over 100 years. Now, if we look at the evolution of connectivity, recently, it's an exponential phenomenon. Over the last few decades, these little devices, smart as well as cell phones, have connected literally billions of people across the face of the planet. Phase 2, we envision the industrial assets of the world, things that GE makes like locomotives, power turbines, wind turbines, healthcare equipment, all kinds of incredibly complex systems that create enormous amounts of data being connected into machine-to-machine networks with artificial intelligence. And ultimately, these networks are going to have trillions of both digital and physical objects embedded in them. So we see this new dynamic network built out of people and intelligent machines. There'll be distributed devices, software, and minds all working together to create innovation. But it is being limited by the speed and the ability to design, test, and manufacture these increasingly complex physical systems. So as system complexity continues to grow exponentially, we need new platforms that are going to capture the ideas, create designs, exchange data and models, and simulate in real time using high-performance computing resources when needed. And this development time and cost that's increasing with the traditional methods is just not going to work. So what if we could speed up this whole process by fivefold? What if we could cloud enable this whole design to manufacturing process? And what if we could transform the whole manufacturing paradigm, from ideas to materials integration, all the way to existing and novel manufacturing modalities like additive manufacturing? So we have come up with a platform that we call the crowd-driven ecosystem for evolutionary design. It allows users to bring all kinds of models and data that describe their problems as well as their solutions, including manufacturing equipment and manufacturing scheduling. So in one distributed global environment, we can have a collaborative crowd in real time with elasticity. So the Seed platform basically creates a global service marketplace, and it allows individual users to orchestrate their own workflows. And it allows this pervasive collaboration environment to spontaneously build and then drift away as the objects are created. So this actual project started about 2 years ago, was the first commercial use of Amazon Web Services GovCloud. And we chose it because we wanted an ITAR compliant environment. It had to be certified and accredited. It had world-class delivery capability. And of course, we wanted it to be deployed on a global stage. Another important feature of this environment It's collaborative, but it's also federated. A lot of people that have intellectual property do not want to necessarily put all their information in one central location. This system allows us to take the advantage of the cloud, but also distributes a lot of the models, the tools, the data in various places all around the world, while maintaining all the governance, the controllership, and ownership, which is obviously very important to people in the business world. So when you put this all together, you get a very flexible, elastic environment running on EC2. It allows for both rapid prototyping and simulation, and ultimately building real parts that are going to be put together into very, very complicated, complex systems. These teams come together very quickly and naturally. They exchange their data and their models based on their business rules, their business models. The system does not force them to take one particular route. So when we look at this, we think this technology really holds the promise to really change the way manufacturing is architected, transform the way we create these very complex physical and software systems. We are actively participating with new partners. We're looking for new partners. I hope we can continue the discussion on Twitter, so please connect to us. I would also like to say that I would hope you would all join with me in looking forward to another 100 years of economic prosperity and growth, this time driven by an incredibly sustainable industrial internet revolution. Thank you very much.